Okay, here is final exam review, number 21 out of 21, or 9.4.30. Let me just jump into it. Early in 2010, 38% of subprime mortgages in a certain country were in distress, meaning that their holders were either foreclosed or being foreclosed or at least 90 days delinquent. The federal government is hopeful that the percentage has declined due to a mortgage aid program that was initiated during the year. To test this hypothesis, a random sample of 400 subprime mortgages was selected later in 2010. From this sample, it was found that 146 mortgages were in distress. Using an alpha of 0.1 or 10%, answer the parts A and B below. Okay, so A is, what conclusions can be drawn about the proportion of mortgages in distress? Determine the null and alternative hypotheses. So in this one, we have to read through this, and what we're trying to find out is whether or not the number of delinquent or distressed mortgages has dropped. Okay, so this is not a case where we're going to use equal to or not equal to. We're looking for a null hypothesis that it is 38% or greater, and our alternative would be that it is less than 38%. Remember, null is the status quo, and then alternative is that there's been a change, and in this case, a change that we're looking for. So we want to see a null hypothesis where P is greater than or equal to 38%, and an alternative where P is less than 0.38. Now we're supposed to determine the critical values of the test statistic. So determine the critical value. What we're going to do is we're just going to use the norm.s.inv function. There's also a table we could look this up in. And we're going to use our alpha as a probability. So in this case, it's 0.1. So there it is. There's our critical value. Negative 1.28. They want 2 decimal places. What that means is if our test statistic falls below that critical value, then we're going to reject the null hypothesis. Okay? So now we have to calculate the test statistic. In order to do that, we need some information. We're going to need the bar P, which is really just the proportion of the sample. So we can find that by taking the number of mortgages that were in distress in the sample, which was 146, and dividing it by the N, or the number of total data points in the sample, which is 400. That gives us the proportion, or 0.365. We're also going to find the proportion from the null hypothesis, which is given to us as 0.38. And our N, which is given to us, that's the number of data points. Whoops, we want N, which is 400. Then we can calculate our test statistic by saying that the test statistic is equal to the bar P minus the null hypothesis. Then we're going to divide that by the square root of the bar P, no, the null hypothesis times 1 minus the null hypothesis. And we'll divide that by N. And that gives us a test statistic of negative 0.0 0.62. Uh-oh, it doesn't like that. Let me make sure my calculations are right. I see what I did. I put a 0 in there where I shouldn't have, negative 0.62. There we go. And then we have to determine the conclusion. So remember, we decided that this was our critical value, negative 1.28. And here's our test value. And we said that if our test value was less than our critical value, then we would reject the null hypothesis. So in this case, it's not less. So we're going to not reject the null hypothesis because there's not sufficient evidence to conclude that the mortgages in distress has really dropped. And that should be, oh no, it wants a p-value too. All right, so to calculate our p-value, we're going to use another function in here, so p-value, that will return the probability of that test statistic actually occurring here. So this is going to equal norm for normal dot s dot distribution test statistic comma true. And since this is just a one-tailed test, yeah, that'll be our answer. If it were two-tailed, we'd have to double it, right? They want 3 decimal places, so it's 0.268. There we go. That is 21 of 21.